Alright, in this video we've got a graph, a couple lines, and we want to come up with the piecewise function that represents this graph. So the first thing we're going to do is call out this green line right here. We need to come up with an equation that represents that. So I'm going to use my y equals mx plus b, okay, with my m being the slope, my b will be the y-intercept, and I just need to fill those in. So y will be our slope for this green line. You'll notice that here's a solid point here, another solid point here, another solid point here, so it's going down one over to the right one, down one over one. So the slope would actually be, well, we'll say m is 1 over 1. That will be the slope. And then it's going to be negative since it's decreasing. The y-intercept then will be right here. The line is going to go through the y-axis at 1, 2, 3, 4, 5. So our b would be equal to 5. So I'm going to plug that into my slope-intercept form. So that's going to be a negative 1x plus 5. And that's my line, okay? Now, we only want this line, though, whenever the x values are equal to 1 or less than 1. So x's will have to be less than or equal to 1. And I'll call out some points here. And you'll notice that indeed all the x values, for example, here is 1, here's negative 1, here's negative 3, they're all less than or equal to 1 right here. So that's our green line. Let's move down to our blue one. So we're going to do the same thing. We're going to call out y equals mx plus b. We're going to fill in our m, which is our slope, and our b, which is our y-intercept. So if you look at this line right here, we've got a solid point right there, and then we have to go up one, another one, and then up a third one, and then over one to get to the next point. So you'll notice that the slope is up 1, 2, 3 over 1. So our m will be 3 over 1. Okay. Then our b, well, can you notice where this line crosses the y-axis at all? And you can't see it, but if we extend that line, so if I keep going this way, you'll notice that it goes through the y-axis right about there. And then if I count down 1, 2, 3, 4, 5, you know that the y-intercept will be at negative 5. So we could fill that in as well. And if you think about the slope, well, if this is our y-axis, we know our slope is, if this is our y-intercept, we know our slope is 3 over 1. We go up 1, 2, 3 over 1, and there would be our another point. So that checks out. So let's go ahead and plug all that information into our line right here, the equation of our line. So our m is 3, and then we've got x minus 5. But we only want that when our x values for this line are at, looks like that x value would be positive 1. So we only want that when x's are greater than positive 1. We don't want to include this point because it's an open point. So x equals positive 1, that's not included in this line, but it's the end point basically. So let's go ahead and write a formal piecewise function for this, and that will be our final answer. And there it is. So to recap all the steps that we did, we basically just started with y equals mx plus b, the equation of a line, and then we filled in our slope, our y-intercept, which gave us our line, and then we came up with an inequality that represented what part of that line that we wanted, so that's going to be our domain. And then something to be careful of is if our line doesn't actually extend through our y-intercept, our y-axis like this to give us a y-intercept, we have to extend the line so that we can see where it would go through the y-axis, which we had to do with our blue line. And that gave us our y-intercept of negative 5. So that's that.